So this video is continuation of Hess's law, and in here we will review two practice question how to solve using Hess's law. So calculate the delta H for the reactions shown below, where C2H4 gas when react with fluorine gas to form carbon tetrafluoride gas and HF hydrofluoric gas, and we need to find out delta H for this reaction using these three reactions. So how we will solve this questions? As I said, we have to use our puzzle trick to solve this kind of questions, and first we will do label each reaction as reaction number 1, reaction number 2 and reaction number 3, and then we will try to find where are the desired reactant and product are. So you can see in this reaction HF is on the product side, which is good, but here is only 2 moles, but in the desired reaction we need 4 moles. And in the second reaction carbon tetrafluoride is also on the product side, which is nice, but here we have only for 1 mole, but here it is 2 moles. And in case of third reaction, this C2H4 is on the product side, but we need this on the reactant side to solve this question. So what we will do this first we will multiply reaction number 1 by 2, because we need 4 HF on the product side, so we have to multiply this whole reaction by 2. So once we will multiply 2, this will become, and I will label this as a reaction number 4. So this 1 H2 gas will become 2 H2 plus 2 fluorine F2 and then 4 HF gas. Same time, don't forget to multiply this delta H also. So delta H minus 537 multiplied by 2 will be equal to 1074 kilojoule. Next is reaction number 2. We will multiply this as well by 2, because we need 2 moles of CF3 on the product side. So just multiply by 2, so this will become 2 carbon and 4 fluorine and then 2 CF4, and then we have to multiply 2 680 kilojoule multiplied by 2, this will become 1360 kilojoule. And in the third reaction we have to flip this reaction, because we need C2H4 on the reactant side. So flip reaction number 3, so this will become C2H4 gas, 2 carbon, because there are already 2, and then 2 hydrogen, and then 2 hydrogen, and then we have to change the sign of delta H as well. It is 52.3 in positive kilojoule, but this will become negative. Once you will done all these three reactions, then you can cancel out the common thing. So hydrogen 2 molecules on the reactant side, hydrogen gas 2 molecules on product side can be cancelled. Carbon can also be cancelled, and then you can see fluorine I'm not going to cancel, because we need 6 fluorine in the reactant side. So we have 4 fluorine and then 2 fluorine, so we can add together. So once you will add all these reactions, so this will become C2H4 gas plus 6 fluorine gives out 2 CF4 and then 4 HF, and then all the other product will be cancelled out. And on the same side, way we have to add all the delta H also. So delta H will become minus 1074 kilojoule plus minus 1360 kilojoule plus minus 52.3 kilojoule. Once you will add all these, this will become minus 2486.3 kilojoule. And now this will be your reactions, and the delta H would be this will be for this reaction. So this is the way we can solve the Hess's law question problem. Let's see one more example in this series, where they are saying that calculate the delta H for the following reaction, where iron oxide is reacting with carbon monoxide to produce iron and carbon dioxide gas. So they have given 3 reactions: iron oxide, carbon monoxide, and then ferric oxide from ferrous to, and then carbon dioxide gas, and then iron is reacting with carbon dioxide gas, and then the third one, and each have the delta H. So how we will solve this question? Once again the same way. So I will give each reaction number 1, 2, 3, and then we can figure it out that what we have to do. So you can see the 3 carbon dioxide gas on the product side, and this have 1 carbon dioxide gas on the product side. We need not iron 3 and oxygen 4, but leave it as such. In the second reaction, iron must be on the product side, but this is on the reactant side. And then in the third reaction, carbon dioxide gas and Fe3. So probably this will not be changed. Okay, so let's start. So first we have to divide this reaction number 1 by 3. Why we are dividing? Because we need to cancel iron 3, Fe2O3, and we are dividing by 3 right now to make 1 by 3rd carbon. So basically we are dividing because we need 1 mole of Fe2O3 on the reactant side. So once you will divide 3 by 3, 1 by 3 CO2, and then 2 by 3 Fe3O4, and then 1 by 3 CO2. Same time you have to divide this delta H also. So delta H will be 48.5 divided by 3 will be equal to minus 16.17. So once you will divide and solve this reaction, so this will become 1 mole and 1 by 3rd CO2, and then 2 by 3rd Fe2CO4, Fe2O4, and then 1 by 3 CO2. Next, and then I will give this reaction number 4. Next we have to flip and multiply reaction number 2 by 2. Why we are flipping and multiplying? Because we need 2 iron on the product side, and this iron is 1 on the reactant side. So we have to flip this reaction on the and then multiply. So I just flip this reaction, and this will become 2 CO and 2 FeO gives out 2 Fe and then 2 CO2. So here you can see we are just flipping the reaction. Sign will change from minus 11 to plus 11, and then we are multiplying this. So this will become plus 22 kilojoule. And then third is reaction divided 3 divided by divide reaction, or actually this will be multiply. So rather than divide, it should be multiply. Multiply reaction 3 by 2 by 3. So 2 by 3 Fe3O4, 2 by 3 CO, and 2 by 3 FeO. Basically this is already 3. Yes, so the 3 will be cancelled out, correct. So 2 by 3 CO, and then what will happen? So 3, and you can see when we multiply by this reaction 2 by 3, so 3 will be cancelled out, 3 will be cancelled out, only 2 over the main. And then now you can see 2 by 3 Fe4 on the reactant side, and on when we'll combine reaction number 4, reaction number 5 and reaction number 6. So add all these three reactions, and here also the delta H for this reaction number 3 will be multiplied by 2 by 3, so this will become 24 by 3. And then now can add. So once we will add, the iron Fe 2 FeO and 2 FeO will cancel out, Fe3O 4 Fe3O will also be cancel out, and then we can add all these three. So Fe2O3 and then 1 by 3 CO, 2 CO plus 2 by 3 CO. So once you will add all these three, so this will become 2 by 3 CO and plus 2 by 3 CO. This will become 336 divided by 2 plus 2, 4 and then 5. So and then once you will add the iron, so iron will become 2 iron and then 2 carbon dioxide gas plus carbon monoxide gas, carbon dioxide gas 1 by 3rd and 2 and then 2 by 3. Once you will add, this will become 3 by 3. So at the end, once you will calculate, this will become Fe2O3 CO and 2 iron and then 2 CO2. And the same way we have to add their delta H also, and then at the end you will get plus 20.5. So here is important thing, once you will add all these things, you have to consider that which product, which molecule will be on the reactant side and which will be on the product side, and how many moles, because we need to arrange their coefficient also in the final reaction using the steps. So these were the two examples on the practice problem with Hess's law, and try to solve some more examples so that you can learn. And then if you have any question, just let me know.